Hello together. Thank you for having me here and the warm welcome. I would like to start with the agenda. First thing will be to present a little background about myself. Second topic will be to outline the services which I can offer. The reason why I have the chance to speak here is because Sartorius and my company have something in common. Let's find out what this could be. Also, I've built a small practical case which I did recently to highlight my specialties. And as always, we close the round with a little Q&A session. Before that, I would like to introduce myself. My name is Stefan, and I'm an engineer. With my family, I do live in the very southern part of Bavaria, close to the Austrian border. In 2003, I had the first contact with DE as a validation engineer and did some really cool stuff for optimization and stabilization of processes. This motivated me a lot to get a little bit deeper into statistics. Since then, I had done a lot of trainings, coachings, and workshops on DOE in a wide range of industries from life science to automotive and pharma. Of course, my background as a Design for Six Sigma specialist helps me to know the right methods to develop optimal strategies related to DOE and MVDA. As you can see here, I had a rather unconventional balance working both as an employee and as a freelancer. This makes my day somehow more interesting. I mentioned earlier that I teach a variety of Design for Six Sigma courses as a freelancer, and the courses I prefer most are DOE and MBDA trainings. The courses take place both in the university and in the industry. This brings us to the point that Sartorius and I have something in common. We both love statistics and methods that lead to success when possible. We both have a strong interest in bringing the knowledge of DOE and NVDA to the people who want to learn it and make a difference. Another thing we have in common is that we have high expectations of ourselves, the way we teach, and the effort we put into our learning materials. We all know that coaching and guiding someone during development and optimization is not necessarily easy. It takes a high level of intrinsic motivation, a well-prepared setup, and a high level of experience to combine methods and knowledge with the needs of the customers. For this reason, I created my extensive free tutorials to always find better ways to transfer the knowledge to the customers. You can easily find and access these tutorials in my posts on LinkedIn or in the Umetrics user group on LinkedIn. Of course, some of the content can also be found on my homepage. From my early DOE courses, I was concerned with setting a high didactic standard in my courses, which is why I developed the DOE cooking recipe. Any participants who has taken a course once can easily guide themselves through the DOE by strictly following the cooking recipe. But before it gets to the point where people do their own thing, the Kanban during the course really supports me in showing the common thread throughout my DOE course. And it really helped the participants not to lose the connection. Okay, I think now you have a good overview what I am doing to support my customers. Let's take a look at a specific project that I did with Thomas Netzel from AFNTS. In this project, we supported a customer in the area of non-target screening. Our task was to develop a test method capable of detecting 30 anthropogenic substances that possibly occur in surface waters such as rivers or lakes. An electrospray ionization system served as a test device, which was coupled with a liquid chromatography for mass spectrometry to analyze the liquid samples. In this process, a chromatographic system retains the components of a complex mixture according to their psychochemical properties and the distribution between the carrier liquid and the stationary phase. Then the isotopes convert these neutral molecules into gas phase ions by separating the sample solution into a cloud of charged droplets, and then gradually evaporating the solvent until only gas phase ions remain. In the mass spectroscopy, these ions are accelerated and deflected by electric and magnetic fields to determine the precise mass-to-charge ratio. There is a variety of adjustment parameters that affect the ionization efficiency of an IC source to varying degree and can have opposing effects and interactions. The ionization of compounds in AC depends not only on the adjustable parameters, but also on the compound itself. This raises the question of the most appropriate combination of setting for general but sensitive operation. In this study, ionization efficiency was measured using the signal intensity of 30 model compounds. They covered the entire rotation time window of chromatographic run to represent the complex and non-uniform composition of solvents. Of course, I'm not the lab expert and do not have the chemical or physical knowledge to explain this in detail. My task was to figure out how to break this down to an investigation using DOE. To estimate the rough parameter settings and explore the right important factors in the appropriate ranges, we conducted a workshop with the customer using methods such as SciPoc or Ishikawa diagrams to find the right study space for our DOE setup. At the end of the workshop, we agreed on 6 prioritized factors. After this, we made an estimate of the needed experiments based on the DOE planning. At this time, the preparation of the test samples was started by the customer. To ensure that our study were conducted in the correct investigation space, we began with a fraction factorial screening design. After this pragmatic pre-runs, we had only to do minor adjustment to our initial setup to perform the needed experiments in the appropriate space. The trick to analyze data from 2 instruments is to link the data together. Therefore, we used an access database, in which we linked rotation time to mass. In this way, we were able to detect all substances in a run as they occurred. We called this approach mass at retention time. By default, this method was not set up to quantify all substances, but to ensure that they would be detected by the method. Of course, this meant that single individual concentrations had to be adjusted to avoid shadowing effects. After importing the results of our study in form of count from the AC system, we developed a model for each of the 30 substances. This helped us to optimize factor settings so that all substances could be detected with an optimal setting. In a software model, we have therefore some really handy algorithms, like the simplex solver, to find out where our predefined expectations can be fulfilled or not, or how extensive contradictions are if the requirements cannot be fulfilled. In our case, it was possible to find a setting where all the substances could be detected. The optimization parameters were derived from the observed counts, mass, and retention time of the individual substance models. To this end, we defined a realistic threshold for the counts to ensure that we were likely to have detected all substances, even if we know that the counts detected are also linked to the concentration of the individual substances in the sample. From this set point, we conducted a robust set point search, which is based on Monte Carlo simulation. From this new defined robust set point, we then used the software to move the robust set point to ensure a maximum distance between the set point and the critical factor boundaries. This was done by using the Manhattan distance algorithm built into the software. In other words, we maximized all factor tolerances for all substance models simultaneously. In doing so, we emphasized a holistic design of tolerances, as wide as possible and as tight as necessary. The calculated area, with the defined low probability of not violating the desired outcomes, is called the design space. Of course, in the next step, one can again restrict factors that are easy to adjust in favor to factors that are more difficult to adjust, but that would take us too far here and now. As a conclusion, we can say, using the model, we were able to calculate an overall robust set point to further specify the new method. In addition, the multivariate data analysis made it very easy to cluster these 30 substances, which would make it easier to select representative substances from the study to expand or to adapt the method to additional substances as needed. Now we reach the end of my small presentation. Thank you very much for listening. If you have any questions, I'm happy to answer them.